So what is an isotope? Isotopes of any atom is just like a regular atom, but it has an extra neutron. That all atoms, like oxygen for instance, has both electrons, protons and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons have no charge. So they can be attached to the nucleus of an atom and not really change the chemical composition, but they do change the weight. That if we think of an atom like oxygen, it has 8 protons and 8 neutrons in its nucleus. There's a special kind of oxygen where it's got a few extra neutrons in the nucleus, and in particular sometimes there's 2 extra ones. So there's 8 protons and then 10 neutrons. So the isotope is slightly heavier than regular oxygen. Oxygen is in water as H2O, and so some water in nature is slightly heavier than other water. And so we can use this isotope ratio, the ratio between the oxygen 18 and the oxygen 16, to help fingerprint where water is coming from. And for the experiment we're going to do, we're going to think of the analogy where yellow water, it's kind of a warm color, so we're going to pretend that's water from the Gulf of Mexico, and blue, it's sort of a cold color, so we might think of that as being from the Pacific Ocean. So the measurements we're looking to do is to help figure out what that fraction is, and we can simulate that here in this experiment. So let's assume that we have water here in Colorado, the precipitation here in Colorado, and we can have it as a mixture of a whole bunch of water from the Gulf of Mexico, and some of our water is also coming from the Pacific Ocean. And what we find here in Colorado is a combination of these two, and it gives us green, which is halfway in between, or somewhere in between. If we look at our color differences, we can see that the color, it's kind of green, and it's pretty much dominated by mostly water from the Gulf of Mexico. And so by looking at the combination we get here in Colorado, we can figure out where the water is coming from. So to stop the evaporation, we're first of all going to put oil into the system, into the collector, with the idea that oil will float on top of the water and oil won't evaporate, so the water will be safely not evaporating down below the oil. And all we need to do is pour in some oil into the collector. In it goes, and we only need enough in there so that we have about 1/2 inch of oil on top of the water. So here we have just regular water with some blue food coloring in there so we can see what it looks like. We can imagine that either it rains or snow falls in here and then melts. As the rain goes in, you'll notice it drains through the oil and it goes to the bottom. So now we've got our sample, our rainwater in the bottom with the oil on top, and we're ready to collect our sample. We want to completely empty the collector of the water, and so we can start for the collection for the next time. So we have a large bottle or a beaker or some other sort of container. We want to drain it all out. And so now we have our water in another jar, and we want to transfer that into our sample vial. So first of all, we want to be sure that this is well stirred so there's no settling of our sample. So we give that a good stir, nicely stirred, and we want to just pour that into our collector. You can probably pour it straight in, or we can use a little funnel to help us out. So we want to fill up the bottle, the sample bottle, not all the way, to maybe about 80% full. So there we have our vial. Put the cap on nice and tight so it doesn't evaporate, and you'll notice that it's about 80% full, which is important because if this freezes, the frozen water will expand and it won't crack the bottle. So now we write a label, we write the date and the place, and it's ready to ship. Thank you very much for collecting these precipitation samples for us. It's giving us a great idea of where water is coming from in the precipitation in Colorado and makes for very valuable research. Thanks a lot.